In Puerto Rico, the world's largest radio telescope aims at a distant star. Scientists monitor it around the clock, hoping to detect an artificially generated radio signal, evidence of an extraterrestrial civilization. At the Lick Observatory near San Jose, California, astronomers search the heavens for a high-powered light beacon, a calling card beamed by extraterrestrials from a solar system trillions of miles from Earth. Meanwhile, 4 NASA space probes launched in the 1970s carrying information about our planet continue their journey to worlds far beyond our solar system. These are a few of the ways that astronomers have been searching for intelligent extraterrestrial life, or ET himself. But just what do these searchers consider intelligent?
If you can build a radio transmitter or a high-powered laser so that we can detect you, then from our point of view, you're intelligent.
While encountering intelligent life might be the pinnacle moment in human history, scientists are no less eager to encounter extraterrestrials that can only be seen under a microscope.
Let's say if we go to Mars and we find evidence of microbial life, there are actually 2 things it could mean. One is that life on Mars and Earth are related. Somehow they're products of the same event, and as time went by, Mars can no longer sustain life. And so we may be looking at an ancient, distant cousin. The other possibility is it started of its own origin, not of Earth, but of Mars itself. Now that has the possibility of giving us a whole nother example of what life is like.
The quest to discover if life exists on Mars has been a great scientific drama for more than 100 years. In June 2003, the next act would involve a 9-year-old girl, the winner of a nationwide essay contest to name 2 robotic explorers headed to Mars in search of life.
She has in her heritage and upbringing the soul of 2 great spacefaring countries, to be sure.
Sophie Collis was adopted by an American family from an orphanage in Siberia.
At night, I looked up at the sparkly sky. I felt better. I dreamed I could fly there. In America, I can make all my dreams come true. Thank you for the spirit and the opportunity.
Spirit and Opportunity are twin 400-pound solar-powered geologists. If all goes well on their 7-month-long journeys, they will land on Mars to conduct life-seeking missions in January 2004. They are the larger, more technologically advanced offspring of the Sojourner rover that explored Mars in 1997. NASA scientists have chosen landing sites for Spirit and Opportunity where they think water might have once existed. Because where there's water, there could be life.
There may be boundaries of grains could contain liquid water, and little microenvironments, microclimate areas could form. They could be niches. Martian life, if it exists, and we don't know, might actually have found pathways to go there and live in those tiny environments.
But before Spirit and Opportunity could visit Mars, they had to pass a cleanliness test given by a scientist with an out-of-this-world title, the Planetary Protection Officer.
I work to make sure that we don't contaminate other planets with biological materials from Earth, and that if we bring something back from another planet, we check it for life before we distribute it widely here on Earth.
Rummel and his team were involved in the earliest stages of the Mars mission to assure both rovers were built under the cleanest of conditions. Some parts were even sterilized through oven baking prior to assembly. Then, as Spirit and Opportunity were going through final launch preparations, the protection team continually collected culture samples from the rovers, making sure they were clean enough to go to Mars.
You may look at a tabletop and not see the life that's there, but in fact it's very abundant. And a typical tabletop in an office is way too dirty to be sent to Mars.
While it's virtually impossible to remove every single microorganism, the acceptable limit for Spirit and Opportunity is 300,000 aerobic spores.
That's about the same amount of microbial life as you would find in half a bottle of water that you'd buy in a machine or at the store. Very small bottle of water, in fact.
When Spirit was determined to be well within those parameters, It was encased inside the capsule-shaped spacecraft that will carry it to Mars. It was then transported to the launch pad, lifted more than 100 feet off the ground, and secured inside the fairing, or nose cone, of a 3-stage Delta II rocket.
4, 3, 2, 1, engine start, and liftoff of the Delta II rocket carrying the Spirit from Earth to planet Mars.
And there's jettison. Solid motor jettisoning.
NASA animation illustrates how both it and Opportunity, launched on July 7th, will land and work on Mars. 37 minutes after launch, the capsule containing the rover separates from the rocket's 3rd stage. It's attached to a cruise stage, equipped with solar panels, which provide the rockets, bringing it to a near stop.
So we will cut the bridle and now drop to the surface of Mars, hitting the surface at something like 25 to 40 Gs, enough to black out a human being, but not our rovers.
The rover, nestled inside its cocoon, begins bouncing across Mars, perhaps covering a full mile before finally rolling to a stop. The airbags deflate and retract. Landing pedals open up in such a way that the rover will be turned right side up, regardless of its position on landing. Next, the rover unfolds its power-generating solar panels and deploys a mast on which panoramic and navigational cameras are attached. They provide controllers on Earth, a set of eyes on Mars.
And if all goes well, we will receive the signals from those rovers and begin a type of expedition that will be previously unexperienced in our human condition.
The rover then rises up from a crouched position.
And as I like to tell everyone, I've never met a rock that lied to me, if you can read them right. So we have the tools to read the rocks.
Though it's possible for Spirit and Opportunity to discover life on Mars, scientists aren't overly optimistic. But they do hope the rover's geological research will help clarify where and how to search for life in future missions. While Spirit and Opportunity represent an apex in the scientific search for extraterrestrial life, the roots of that search are ancient. We can't really know when one of our ancestors looked to the stars and wondered if they might glimpse a sign of life. But in the late 1800s, an amateur astronomer would fuel the public's imagination with his theories on extraterrestrial life, and we've been obsessed with Martians and UFOs ever since. Spirit and Opportunity each carry a DVD containing the names of 3.5 million people collected during NASA's Send Your Name to Mars campaign. ET Tech will return on Modern Marvels. We now return to ET Tech on Modern Marvels. Since the invention of the telescope in 1608, countless amateur and professional astronomers have gazed at the night sky, hoping to find evidence of life. In the late 1800s, it appeared that one man had actually found it. Born into one of New England's wealthiest families, Percival Lowell was a Harvard-educated mathematician turned U.S. diplomat, with a passion for astronomy, and Mars in particular. In 1894, he used some of his personal fortune to build the Lowell Observatory in Flagstaff, Arizona, and equipped it with the most advanced telescope of his day. He dedicated the facility to the study of Mars. Lowell published his findings in several books, and for the first time, the search for extraterrestrial life had become a widespread public sensation. But ultimately, it was all an illusion.
Lowell made maps of Mars, which were in many respects good maps. But he was one of those observers who tend to see lines connecting the features of Mars, and Lowell saw lots and lots of these. And he went on to speculate that these were canals.
His exploration of Mars suggested to him that there was a civilization there, that it was teetering on the brink of destruction, that Mars was a planet that was drying up, and that the people who lived there, or the entities that lived there, had created canals that would bring water from the poles to the various parts of the planet.
It was never so much science as it was a scientifically based flight of imagination.
Still, Lowell touched a nerve with the public, who were growing more and more fascinated with Martians. And on Halloween Eve, 1938, that fascination led to sheer panic. Orson Welles' radio dramatization of novelist H.G. Wells' War of the Worlds convinced thousands of Americans that invaders from Mars were attacking Grover's Mill, New Jersey.
I'm extremely surprised to learn that a story which has become familiar to children through the medium of comic strips and many succeeding novels and adventure stories should have had such an immediate and profound effect upon radio listeners.
Following the War of the Worlds broadcast, and through the post-World War II years, Americans were reporting so many UFOs that in 1947, the Air Force initiated Project Blue Book to investigate and document the sightings.
In the immediate post-World War II period, adults and children alike were in possession of these airplane cards which had silhouettes, and you would look up in the sky and spot whether an airplane was friend or foe. And I suspect that had something to do with the UFO craze, because once people start looking up expecting to see flying objects, and then if they see a light or something that they can't identify, it becomes an unidentified moving something.
Walter Cronkite examined the UFO phenomenon in a 1966 primetime documentary.
From the beginning of recorded time, men have been seeing unexplainable things in the sky. And there's no reason to doubt they saw something. The question is, was what they saw really there? And what was it they really saw?
Cronkite and other reporters interviewed eyewitnesses, and even those claiming to have been on board flying saucers.
And they had a compartment in the wall which both cleans and deodorizes their clothes by some light process, which required no water, soap, or detergents, or a washing machine.
Also interviewed was a young astronomer from Cornell University, who would go on to be a seminal figure in the scientific search for extraterrestrial life. But Carl Sagan felt the UFO phenomenon was rooted more in religion than science.
It's a way of having beings that come from the sky that are worried about us, that are powerful, that are going to step in and prevent us from destroying ourselves, as we very well might, and yet have it in the cloak of science.
Amidst charges by UFO witnesses of a government cover-up and conspiracy, the Air Force terminated Project Blue Book in December of 1969. It documented a total of 12,618 sightings. 701 remained unidentified.
When it comes to extraterrestrial life, I really don't believe that there's a cover-up here. To begin with, I'm not quite sure why the government would want to keep that secret. But, hey, even if you want to believe that they would keep it secret, do you think that every government wants to keep it secret? Are the Bulgarians keeping it secret, right? Are the Czechs keeping it secret? Are the British keeping it secret? Right? Or do the aliens only land in America, so only one government has to be worried about this?
In 1960, during the height of the UFO frenzy, and when the space program was still in its infancy, a radio astronomer named Frank Drake gave the world its first legitimate scientific method of searching for extraterrestrial intelligence. Radio astronomy emerged as an important science in the late 1930s, with the discovery that celestial objects like galaxies, their stars, and even planets emit naturally occurring radio waves that can be detected on Earth by radio telescopes. Always built in remote areas to minimize interference, a radio telescope's large dish collects the waves and bounces them up to a reflector. The reflector focuses the waves, then feeds them to a receiver located at the bottom of the dish. The receiver amplifies, then transmits the signal to computers. Scientists can then analyze the radio waves and create visual representations or maps of the object from which they originated. On Earth, man-made radio waves generated by radio and television broadcasts have been traveling through the universe for about 100 years and could conceivably be detected by extraterrestrial civilizations that also have some form of radio technology. And conversely, we could detect their transmissions.
I think it's likely that all civilizations pass through an era as we are now passing through, in which we have very high-power television broadcasts which can be detected by other civilizations. There will be such a period. Other civilizations will have their I Love Lucy, and we can capture it, and it doesn't take much to do it.
In 1960, Frank Drake was a radio astronomer at the newly built National Radio Astronomy Observatory in rural Greenbank, West Virginia. That year, Drake began aiming the observatory's radio telescope toward select stars in hopes of detecting radio waves that had an artificial signature, the broadcasts of an extraterrestrial civilization.
When we were observing, we didn't listen because the signal that comes out of a radio telescope is just static and noise unless there's really a signal there. But we had a pen and ink recorder. Then you watched the squiggly line and you hoped that at some point the pen drawing the squiggly line would jump over to one side, which is what you would get if there was actually a signal being detected.
Drake named his experiment Project Ozma after the fictional Princess of Oz.
The land of Oz was a land far away, very difficult to reach, and populated by strange and exotic beings. And so that's a good description of the place we're trying to find.
While Ozma never detected an intelligent ET signal, it laid the foundation for what would become known as SETI, the search for extraterrestrial intelligence. SETI would come to be the acronym applied to all radio telescope searches for artificially generated radio waves. But in 1960, the public wasn't thinking about radio telescopes. If we wanted to meet ET, we'd just blast off in a rocket and go see him. The world's first radio telescope was built by amateur astronomer Grote Reber in 1937 in his backyard in Wheaton, Illinois. He used it to make the first radio maps of the sky. ET Tech will return on Modern Marvels. We now return to ET Tech on Modern Marvels. The race to the moon highlighted America's space program in the 1960s. But even during the earliest days of the program, NASA was also pursuing planetary exploration and the search for life using unmanned probes. The first series of planetary probes, named Mariner, were destined for our closest neighbors, beginning with Venus.
Venus is covered with clouds, so for many decades, observers could tell almost nothing about it. In that absence of evidence, a lot of speculation flooded in about how, well, if it's cloudy, Venus must be like a rainforest, and under there would be these wonderful tropical forests and abundant life forms and so forth.
Mariner 1 was launched on July 22, 1962. Its mission was to survey Venus's atmospheric and surface conditions.
20 seconds and going up very nicely.
5 minutes after launch, the rocket carrying it into space went off course, so ground controllers blew it up, destroying Mariner 1 as well.
This one apparently blew up. It's a big ball in the sky.
Mariner 2 was successfully launched 5 weeks later. After a 4-month journey, it became the first spacecraft to ever encounter another planet when it began orbiting Venus. As it was not equipped with cameras, these images were compiled from a later probe. But Mariner 2's sensors indicated that Venus was an inhospitable planet for life. It has what scientists call a runaway greenhouse effect, with a thick carbon dioxide atmosphere and surface temperatures of 900 degrees Fahrenheit. The search for life then moved to our next closest neighbor, Mars. On July 15, 1965, Mariner 4 flew within 6,100 miles of Mars and began transmitting the first close-up pictures of the red planet back to Earth.
What it showed us was surprising. It saw a Mars landscape that reminded us more of the moon. All of this astronomy, careful thinking, the best measurements we could make from Earth, had shown us a Mars that was dynamic, exciting, possibly life-bearing. And then we saw the lunar face, not a place you'd expect to find life.
But not everyone was disillusioned. Mariner 4 returned a total of 21 grainy black and white photos, covering less than 1% of the planet's surface. A more advanced probe was launched in 1971. Mariner 9 would photograph nearly the entire surface, but it arrived at Mars in the middle of a massive dust storm.
We actually had to wait 3 months before we ever took a photograph of the surface. Mariner 9 happily waited as the dust storm subsided, and the first land it saw was the peak of a 90,000-foot volcano.
The gigantic volcano named Olympus Mons, shown here as photographed by Mariner 9 and then by a more advanced probe years later, is the largest known volcanic edifice in our solar system. Having transmitted more than 7,000 photographs back to Earth, Mariner 9 provided a comprehensive view of the planet's surface using higher resolution photography than prior probes. In addition to volcanoes, Mariner 9 also revealed the Val Marinaris, a 3.5-mile deep canyon, long enough to stretch from New York to California, and numerous dry river channels. The combination of internal heat generated by volcanoes and flowing water would have provided ideal elements for past life. Now scientists had to figure out whether it was still present and how to find it, or look for evidence of its extinction. They would get that chance with Project Viking.
Viking is the big enchilada when it comes to a Mars mission. This was a major effort. It included 2 landers and 2 orbiters, multi-billion-dollar program.
The Viking landers were literal robotic laboratories designed to conduct numerous tests of the Martian surface.
They could look for evidence of internal activity through seismographs, conduct 5 life-oriented experiments looking for the chemistry of life and how life might metabolize in a Martian system, how it might produce chemicals.
Viking 1 touched down at its landing site on July 20th, 1976. Viking 2 arrived 4 months later. The immense thrill of actually landing 2 sophisticated laboratories on another planet soon gave way to a sobering reality. Both landers scooped up and analyzed Martian soil through a variety of tests. But the tested samples showed not even a trace of carbon, the dominant element in the chemistry of life. In fact, scientists concluded that the surface of Mars was self-sterilizing due to the intense levels of radiation it's exposed to from the sun and deep space. The Viking landers, which still remain on the planet, failed to accomplish one important goal that disturbed many scientists.
We never actually touched and analyzed a rock. The little chips of things we thought were rocks in the soil we grabbed ended up being dirt clods. So we did not analyze, with this incredible gear, rocks. Well, as I tell kids when I get a chance, rocks are Mother Nature's artifacts. They tell us the story about how planets are made, environments, what environments the rocks were formed in. So we got to get to the rocks.
In August 1996, 20 years after Viking, it appeared that the rock had come to us. NASA officials announced that a Mars meteorite found in Antarctica contained possible evidence of ancient Martian life. It's believed the 4-pound rock was formed about 4.5 billion years ago, when Mars was warmer and probably contained large bodies of water. Then, about 15 million years ago, a large asteroid struck Mars and jettisoned the rock into space, where it remained until it landed in Antarctica in about 11,000 BC.
A team of scientists doing analysis at a microscopic level, really an electron microscopic level, found what they think are the remnants of some sort of microbial bacteria that looks fossilized. The result of that was a furor that existed in the scientific community for some time, and a debate that still is taking place in the scientific community over whether or not they're right.
The largest of the possible fossils are less than 1/100th of the diameter of a human hair, and their appearance is similar to microscopic fossils of the tiniest bacteria found on Earth. Plans for the first missions back to Mars since Viking had already been drafted and were in the testing phase when the discovery of the Mars rock was made public.
3, 2, 1, release the item.
But now those missions were energized by the renewed possibility of finding life. One of the most ambitious was Pathfinder. Like Viking, it would send a lander to Mars. Unlike Viking, which was stationary, Pathfinder would include a 6-wheeled rover called Sojourner.
So by being mobile, we can go and touch the rocks. We didn't get to them on Viking, even though they were all around us. And that is part of NASA's newly crystallized Mars strategy.
Launched November 4th, 1996, Pathfinder landed on Mars on July 4th, 1997. The next day, to the thrill of its Jet Propulsion Laboratory handlers, Sojourner rolled off the Pathfinder lander and began roaming the Martian surface. Like all the missions before it, Pathfinder turned up no signs of life. But its true accomplishment was to prove the viability of the technologies necessary for more advanced missions, like those of Spirit and Opportunity.
We have ignition and liftoff of Atlantis and the Galileo spacecraft bound for Jupiter.
While much of the search for extraterrestrial life in our solar system has focused on Mars, NASA has launched a small armada of probes to seek evidence of life elsewhere. One of the most significant was Galileo. Launched in 1989 from the payload bay of the space shuttle Atlantis, its mission was to study Jupiter and its moons. Run by a computer less powerful than a Palm Pilot, Galileo experienced a number of technical difficulties on its 6-year journey to Jupiter. But when it began orbiting the gaseous planet 318 times the size of Earth, it sent back brilliant images. More significant is what it found when it orbited one of Jupiter's moons, Europa. It provided photographic evidence that salty oceans exist beneath the moon's icy surface. Scientists now believe life may very well be discovered there, based on where we found it on Earth.
For instance, Lake Vostok is a subglacial lake in Antarctica. This lake is under 3.7 kilometers of ice. It's been isolated from the outside world for maybe 30 million years. And from samples of ice, we find microbes that are from the lake. So this isolated environment has life in it.
Based on Galileo's findings, plans are already underway to develop JIMO, or the Jupiter Icy Moon Orbiter, to gain a deeper understanding of Europa's subsurface ocean. Galileo also raised hopes that life might exist on another of Jupiter's moons, Io. Rather than harboring a salty ocean, Galileo showed Io as a place of huge erupting volcanoes, another environment where life could exist. And it's the very possibility of life that led to Galileo's destruction. In September 2003, Galileo was transmitting the last of some 14,000 images back to Earth. It had outlived its original mission specs by 6 years. But it was also running out of the propellant it used to keep its antenna pointed toward Earth, so that engineers could control its course. Once that control was lost, NASA feared Galileo could find itself on a collision course with Europa, and that it might still be carrying microorganisms from Earth.
If you look at the ethical reasons for keeping microbes off of other planets, you essentially don't want to despoil other bodies that may have their own life and have Earth life come into conjunction with that other life. It's very important that if we go out to learn about a place, that we not find the contamination that we brought ourselves.
So controllers transmitted instructions to Galileo to change course back toward Jupiter, and to then take a 108,000-mile-per-hour suicide plunge into the planet's dense atmosphere. It would be crushed and vaporized by heat and friction before reaching the surface. While NASA probes searched for signs of simple life forms within our solar system, in 1992, the agency initiated a plan to search for intelligent life beyond it. Olympus Mons, the huge Martian volcano, is 3 times the height of Mount Everest. Its base covers an area the size of Arizona. ET Tech will return on Modern Marvels. We now return to ET Tech on Modern Marvels. Nearly all NASA's probes have searched planets in our solar system for signs of life most likely to be microbial in form. But 4 probes launched in the 1970s, all carrying messages for extraterrestrials, continue making their way into deep space. Pioneer 10 and Pioneer 11 surveyed several planets, then were sent beyond our solar system, where conceivably they could someday encounter an intelligent life form. With that in mind, NASA attached a gold-plated plaque to each probe, a greeting card for extraterrestrials. It was designed by Carl Sagan, his wife Linda, and Frank Drake.
We decided we would draw a map showing the location of the Earth with respect to some identifiable objects, pulsars in fact, and give sketches of human beings.
Pioneer 10 sent its final radio signal back to Earth on January 23, 2003. It was 7.6 billion miles away and continuing its journey out of our solar system. 2 additional probes that would also leave our solar system, Voyager 1 and 2, were launched in 1977. This time, NASA created and attached gold-plated records full of images and sounds from Earth.
Hello from the children of planet Earth.
We wanted to show the good side of us. So there's no war picture, there's no nuclear bomb picture, there's no dentist drilling picture. So in a way, the record doesn't give quite a balanced picture of our civilization.
NASA's probes may have been the luminaries in the search for extraterrestrial life during the second half of the 20th century. But SETI, or radio telescope searches for extraterrestrial intelligence, had been steadily expanding ever since Frank Drake started Project Ozma in 1960.
Our spacecraft that go to the planets look for primitive life. With the radio search, we're looking for advanced life, and it's surely not in our solar system.
But it could be in our galaxy. Shortly after initiating Project Ozma, Frank Drake devised a formula that scientists still use to calculate the potential number of detectable intelligent civilizations in our Milky Way galaxy.
I sat down and wrote down all the things you need to know about to predict the number of detectable civilizations in the galaxy. I wrote them all down and I realized, boy, if you multiply them all together, you get the number of detectable civilizations.
The Drake equation is this. Take the number of stars in the Milky Way times the fraction of stars with planetary systems times the number of planets per solar system that are suitable for life times the fraction of suitable planets on which life might actually appear times the fraction of life-bearing planets on which intelligent life emerges times the fraction of civilizations that develop a detectable technology times the length of time such civilizations release detectable signals into space. There is no correct answer. The equation is devised for scientists to insert their own numbers and to draw their own conclusions.
If you put in my numbers, they predict that about once per year in our galaxy, a new technical civilization arises. And that may sound like an awful lot, but this is 1 out of 200 billion stars each year produces a new civilization. So it's not all that wild. At the same time, it's very exciting. It means there have been lots and lots of them produced, and literally billions in the history of the galaxy.
Even as more conservative astronomers calculated the Drake equation, the belief increased that huge numbers of detectable civilizations exist in our galaxy. Several university and private observatories began conducting their own SETI projects. In 1984, the SETI Institute was formed to advance and coordinate SETI research. Then, 8 years later, on the 500th anniversary of Columbus's arrival in the New World, NASA began funding its own SETI project in cooperation with the SETI Institute. It utilized NASA's Deep Space Network telescopes that were usually used to track satellites, and the enormous Arecibo radio telescope. Built in a jungle valley in Puerto Rico, Arecibo is the world's largest and most sensitive radio telescope. Its dish is 1,000 feet in diameter, and its reflector weighs 900 tons.
We started down what we thought was going to be a 10-year-long path to survey 1,000 nearby stars and to survey the whole sky.
The amendment I am offering today will eliminate funding for what I believe to be a foolish and wasteful NASA program.
Less than 1 year later, in 1993, Congress shocked the SETI community by terminating the program's $10 million per year average budget. Overnight, NASA was out of the SETI business.
The problem that existed was members of Congress very much questioned what they referred to as the search for little green men. And specifically, some members of Congress made this a crusade.
Rather than accept defeat, the Institute began a fundraising campaign led by Barney Oliver. Oliver was an executive at Hewlett-Packard who held more than 60 patents, and among other things is credited with the development of the handheld scientific calculator. While on leave of absence from the company, he headed NASA's short-lived SETI program.
Barney just decided that this was something he was going to take on, and he took on a new career as a fundraiser.
Oliver's fundraising effort resulted in Project Phoenix.
Phoenix rising from the ashes of congressional termination.
Today, Project Phoenix examines 1,000 nearby sun-like stars, utilizing the Arecibo telescope, among others. Several weeks a year, SETI Institute scientists visit Arecibo and work in round-the-clock shifts to conduct the search.
The popular image of what it's like to go to the telescope and listen for ET is probably best illustrated by what many people saw in the movie Contact, where Jodie Foster sits on the hood of her car with a pair of earphones, kind of dozes off for 30 seconds, and then hears something that sounds like a major accident in the Philadelphia Symphony Orchestra's timpani section or something like that. That's not the way it is. We don't know quite where on the radio dial the signal might be coming in, so we monitor tens of millions of channels. So you can't wear tens of millions of earphones. That's terribly uncomfortable, not very effective. We sit there in front of a bank of computer screens, and the computers are doing the listening. If the computers decide that this signal looks pretty good, they'll beep at us, they'll get our attention. We will get involved at some point in the loop. But mostly, it's the machinery that's listening for ET.
Compared to Frank Drake's first SETI search in 1960, the power of today's searches have increased by a factor of 100 trillion. But in a universe with billions of galaxies containing billions of stars, that's still not powerful enough to search for life everywhere astronomers would like. There is, however, another power boost looming on the horizon. Radio and TV signals, our beacons to ETs, travel at the speed of light. They reach Mars in as little as 4.5 minutes, and the nearest star besides our Sun in 4 years. ET Tech will return on Modern Marvels. We now return to ET Tech on Modern Marvels. Virtually all SETI Institute searches for extraterrestrial intelligence have relied on the ability to rent time on existing radio telescopes that are primarily being used for other types of astronomical research. Over the next few years, the Institute will begin conducting searches on their own telescopes, 24 hours a day, 7 days a week. The range of those searches will also increase dramatically. This is all the result of a $12.5 million grant made by Microsoft co-founder Paul Allen to construct the Allen Telescope Array in Northern California. The Allen Array will consist of 350 small, inexpensive radio telescope dishes linked together to form a sort of super radio telescope. The array won't offer the sensitivity of the giant Arecibo telescope, but it has other advantages.
Arecibo has the biggest collecting area. It can find a particular signal at a greater distance, but it can only look at one direction at a time. And so in the beam that Arecibo makes on the sky with its large single dish, I'm only going to have one star. But with the Allen Telescope Array, now I've sacrificed collecting area. And what I've gained is this ability to look at multiple directions at the same time and look at multiple stars and speed up my search.
So that means now that we're putting an outboard motor on the Nina Pinta in Santa Maria, the chances of discovery begin to go up. and then after that, we keep putting on more motors because technology, mostly computer technology, allows this basic array of antennae to get faster and faster in their scrutiny of the heavens.
While SETI has always been associated with radio telescopes, the SETI Institute has recently added conventional telescopes to the search in a project called Optical SETI. At the Lick Observatory near San Jose, California, SETI scientists look for light beacons, perhaps high-powered lasers, being flashed toward Earth as a signal from another civilization.
Can we say why they would want to do that? Well, of course, that's alien sociology. We don't know a whole lot about alien sociology, so it's a little hard to kind of second-guess why they might do that. But it would be very easy, perhaps easy to the point of being a high school science fair project for them, to mount a campaign of pinging the nearest 10,000 or 100,000 stars with lasers, hoping that somebody will see their signal.
To detect such signals, a specially designed light pulse detector box is attached to the back of a telescope.
And what happens is the telescope is just aimed at nearby stars, and that box is looking for quick flashes of light, not the steady starlight that any telescope can see, but very short pulses of light, a billionth of a second or less, really quick flashes, because those are things that stars don't make.
If the computers associated with either an optical SETI or a radio SETI search detect a signal, the scientists monitoring them would immediately conduct a series of tests to make sure the computers were correct. They would then ask observatories around the world to examine the signal themselves to confirm the finding.
The first thing that we're going to do, if and when we get the confirmation that we found a signal, is we're going to open the bottle of champagne that's sitting in the refrigerator at Arecibo and do a little bit of celebrating.
Whether newly discovered cosmic relatives will celebrate with us is still a great unknown. But the scientific search for extraterrestrial life will continue for as long as human beings ponder whether we're alone in the universe. The search may even outlive humanity itself in the form of the gold records on the Voyager probes, which will travel through space for centuries to come.
About 5 billion years from now, the sun will expand, swallow up the Earth. Everything we know will be vaporized. But a record of our existence will exist for anybody who wants to learn about us, and that once upon a time, far away in the galaxy, there was a place called Earth and a civilization run by human beings.
And perhaps one other thing will be remembered about those human beings: that one of their greatest desires was to peer beyond the stars and contact a friend.